Hello, welcome back to Physical Geography. We're talking today Chapter 18 in the Desert, Water, Wind, and Time. So, we think of deserts and dry is usually the first thing, right? Sand, wind, dry, dust. And the world's driest desert is in South America on the Pacific coast in Chile, the Atacama Desert. It is actually so dry that there have several areas in the desert where we've actually never seen rain. So it is one of the driest areas. But we talked about El Nino a few chapters back, right? This kind of worldwide reversal of temperature and precipitation patterns that happens roughly every 7 to 12 years. And when an El Nino year happens, that changes everything. Some areas of the desert now get as much rain as a traditional landscape, and so they go from being the driest place on earth to being wet. But because it's a desert, it doesn't handle the water as well as a regular landscape would, and so we have these huge flash floods. But as we've talked about with vegetation, right? If there's no vegetation, if it's a dry, dusty surface, you see increased mud flows and landslides. And so every so many years, this city right here has these huge mud flows. Now, I'm going to have a visitor here in about 10 seconds to say goodnight. So hurry up. Say goodnight.
No, not Daddy.
I'm going to wave. I got to do my lecture, so go ahead. Okay, good night.
I just see Mom, Dad.
Okay, you go see Mama. So, this is the desert we're talking about right here, and this is the city here that has flash floods every so many years. And why is this area a desert? Interestingly enough, this is the Amazonian rainforest, just a few thousand miles away. So, there's a couple of factors that influence that. One, the water here in the ocean is extremely cold, so you have a cold water current, and also you have these tall Andes mountains, which blocks warm, moist air. So it's a combination of many things. And that's what we're going to talk about is what causes deserts to happen. Okay? And then once a desert is formed, how does the landscape evolve? So what is a desert? And the most common thing people think of usually is heat. A desert is hot and dry. But actually it's not temperature, it's dryness. The specific scientific term, I love this one, severe moisture deficit. It just means it doesn't rain much. Generally less than 10 inches of rain a year. So to put that in perspective, Chicago gets 30 inches of rain a year. Okay. Now some areas that are a little bit more than 10 inches may be considered a desert if the amount of water that plants give back within their respiration keeps it dry. So the main cause of aridity or dryness is not heat, it's not mountains, it's actually the subtropical high pressure we talked about earlier on. Remember earlier we talked about the ITCZ, that band of thunderstorms on the equator, and how at the equator the wind pattern is that the air rises? Well, here's what happens. At the equator, right, it's hot. It's hot, warm, moist air. So all the air rises, and when it gets up into the atmosphere, it cools off. And what happens when it cools? Well, two things. One, the air has risen, so it expands. So it goes from it's very expanded, and it also cools off, and it loses the moisture, which turns to rain. So now this air up here is cool and dry, right? Now over here, as it flows away, it's cooled off. So what does cold air do? Cold air shrinks, right? It contracts and becomes heavier. So the cold air begins to sink back down. But this air is cool and dry. Now remember what happens when things shrink, right? They shrink because they're cold, but as they shrink, they begin to heat up, don't they? That adiabatic process. So by the time the air gets back down to the surface here, it's warmed back up, but it's extremely dry. And this happens at about 30 degrees north of the equator and 30 degrees south of the equator. So there are two huge bands called the subtropical highs, and that's actually where most deserts lie. The second main cause are rain shadows. We talked about how mountains can cause this, right? The wind blows in off the ocean here, and as it goes up the face of the mountain, it cools off and loses its moisture, so when it comes back down the other side, it's dry. So deserts often form in the shadow of the mountains. And then the last one, cold ocean currents. I've talked awful lot about the Gulf Stream, and that's a warm ocean current. But there are cold currents. So here in South America, there is a current called the Peru Current, and it travels on the coast, but here the water is cold. And what that does is cold water doesn't evaporate as well, right? Hot water evaporates better. So there's less water evaporating, there's less water vapor in the air, there's less water vapor to form clouds and therefore rain. This is right here, you can see, this is the 30 degrees north band I'm talking about. So this is the Sahara Desert, the Arabian Desert in the southwest United States. These are all caused by the subtropical high. In the southern hemisphere, you have the Kalahari Desert and the Great Victoria Desert. You also have a few that are caused because they are far away from water, like the Gobi Desert is far away from the oceans and behind tall mountains like the Himalayas. And same thing with the desert basin in the United States. So all these factors, subtropical high, cold ocean currents, and mountain rain shadows can all work together or in partnership or by themselves to create deserts. So you can look right here under this is actually from your textbook, but the Sahara Desert, for instance, its main cause of aridity is the subtropical high. Now, weathering, we've talked about this. Weathering usually needs water, and physical weathering needs less water than chemical weathering. So in deserts, weathering that happens is mainly physical. Chemical weathering does happen in the deserts, it just happens much more slowly because there's much less water. And one of the things that happens in deserts is chemical weathering. There's this thing called rock varnish. And so what happens is, on the surface of rocks, you might have maybe a little bit of moisture, maybe some small algae or lichen or on top of the surface, and then dust in the sand gets stuck to it. And it builds this kind of like a finish, almost like a varnish, that if you took a sharp rock, you could scrape away, and you could draw petroglyphs, which look like this. So let me come back to that, right? Petroglyphs are just basically scrapings that are done by man, and they can be thousands of years old. And so right here, you can see that they scraped off that outer rock veneer. And what does this look like? It's pretty easy, I think, to spot. That's a giraffe, isn't it? That's a giraffe, and that's a person. And this petroglyph is, I believe, 8,000 years old, and they found it in the middle of the Sahara Desert. Well, why would there be giraffes in the middle of the desert? It's not what we think about today, right? Maybe camels. But we talk about climate change. In the past, the Sahara was once green. Between 10,000 to 6,000 years ago, there was a different weather pattern, and most of the Sahara Desert was actually a grassland, much like today we find in southern Africa. There were people living there who drew pictures on rocks of giraffes. We also find hippopotamus bones, we find lions, and we find jaguars, right? Most of North Africa today is the Sahara Desert, but up to about between, again, 10 to 6,000 years ago, the vast majority of it was a tropical forest. And what happened was the climate has naturally changed. And now the Sahara is a desert. All the animals just basically migrated south over time. So what happened? Well, interestingly enough, even though you think because the Sahara Desert is hot, we know that at the peak of the wet Sahara, the sun's energy actually peaked. The sun got a little bit hotter for us, just a little bit. So it got hotter, but yet that made it more rainy. How did that happen? How do we know it got rainy, first of all? Well, we can look at old lakes or dried up lakes in the Sahara, and we can actually measure their ancient lake beds. We can see where the water was, and we see that 9,000 years ago, most of the lakes that are today in the dry desert that are maybe dried up had much more water today. So what this tells us is there was a pattern that allowed for much more water to be in the surface. In fact, we think there were several lakes here in the middle of the desert that were bigger than the Great Lakes are today. What happened was that increased heat changed the monsoon pattern. So 9,000 years ago, right, the monsoon where you have the wet summer and the dry winter, the monsoon brought rain all the way up to the middle of the desert. So this just shows you that about 9,000 years ago, there was a very slim sliver of desert, very, very little, between the Mediterranean Sea and Africa. And the ITCZ was up here, so this was all thunderstorms. Today, you can see that that line is much further south. The monsoon has changed, and one of the reasons why is the sun has cooled off just a smidge, but that's enough to dry this line much darker, and you can see the difference. This yellow tan is the Sahara today. We find actually evidence of ancient human settlements throughout the Sahara that as the weather was green, was full of people, And as it got hotter and drier, they began to leave and move. And in fact, we think this is one of the things that caused the ancient Egyptian civilization to arise, is all these people were looking for a place to live that had water, and they all settled on the banks of the Nile. So all of a sudden you have this concentration of people in one small area, and it was like a spark, and civilization ignited because of it. So in the desert, the biggest thing that causes weathering is the wind. So when the wind moves things, it blows sand, it blows dirt, it blows dust. That's called aeolian or wind erosion. So the wind will blow sand, it'll blow dust, and what happens is that actually can carve rocks. So this is a lot like with water, right? The surface load. These are the things that are too big to be light in the air. So small pieces of rock, tumbleweeds, branches, things that roll around the ground. That's the surface load, right? But if you've ever been outside, right, you know that dust can get in the air like smoke. And all dust is really, really, really fine dirt. So fine that it floats in the air. So you can have a suspended load of dust, right? So here an example, this is a dust storm moving into a city. You can see it right through here. Along the surface of the ground, the bigger particles, the sands, the rocks, the pebbles, they move through traction and saltation on the surface load, just like water does. And then the wind moves the suspended load. Here you can see the Arabian Peninsula, the Arabian Desert. Here is actually a sandstorm moving right across. One of the largest areas of open sand in the world is this peninsula. So when that happens, when the wind blows that dust, right, it picks it up off the surface and blows it away. And some of that dust in the air rubs against other things and actually can over time wear down rocks as well. And they call that deflation. So the removal of sediments by wind erosion is deflation. Now, it creates some really interesting artifacts. I'm going to pause this right here, and we'll come back and talk about these processes in part 2.